Hey Manoj.
Hey Rohit, can you hear me all right?
Yeah, I can hear you.
So just let me start sharing my screen.
Yeah, sure. You can start off with introducing yourself and what session you are going to take today, your topic, and I'll share
Sure.
a screen.
Yeah. Thanks, Rohit. Thanks for having me. Really excited to be part of this mini conference or mini event, virtual event, PyCloud. Extremely good lineup of speakers, sessions, and I'm really happy to be part of it. So you're able to see my screen all right now?
Yes, sir. Manoj, we can see.
Okay, so I'll just start the presentation. The presentation is more like a guide for my talk, but most of the stuff I'm going to be showing is pretty much within code and in Azure. So I'll just quickly get started with what the session is about. Um, okay, so apologies for probably a very long title. So essentially, what I'm going to be talking about for the better half of maybe 30, 35 minutes is essentially a solution which brings together three things, right? So the first thing is about leveraging serverless on Azure using Azure functions, and then combining it with the power of cognitive services, which is essentially, in my case, I've used speech recognition, text analytics, and so forth, combining that with the power of functions to do some data processing. Now, in the times we live in, almost every conversation has to have COVID. So I've put COVID in my talk, right? So it almost fits in there, right? So this is a use case that I just thought about for the perspective of trying out how these combinations of technologies like functions and cognitive services can be easily brought together to create some meaningful solution, right? The use case that I'm talking about is from something that I conceived, and I'll talk a little bit about through the talk, right? So it's three things, and hopefully you'll find this useful. A bit about myself. I won't spend too much time. So I'm basically a cloud architect. Worked across product services for the better part of 19 years. I specialize on cloud and DevOps, with my primary focus area being on Azure and the Microsoft tech stack. And you can see my handles here. Feel free to reach out to me offline. Feel free to connect me on LinkedIn. More than happy to be networked with you guys. Right. Okay. So what is the use case and what am I talking about? Um, I'll talk about the use case, right? So obviously we have pretty much the mainstream media is all over the place with COVID, the number of cases, the number of positives, number of recoveries, number of deaths, and so forth, right? So there's pretty much uh, a large amount of data that's just coming in, and we're all overwhelmed with it, right? In fact, everybody's probably got in a habit of just opening up the Johns Hopkins dashboard and looking through the data across the countries, what's happening, whether the curve is flattening, whatnot, right? So that's something that we always deal with. So I thought maybe I'll use this context to create another type of solution where we try to mine some data that's probably something that's not prevalent in the mainstream media, right? Um, so, uh, uh, so, so obviously, there's been a lot amount of information about some basic symptoms, right? Like you have a cough, or you have a fever, you might have difficulty in breathing, and so forth, right? But always questions that come to your back that come to the back of mind is, what's actually happening out there in the front lines, right? With the COVID hospitals, with the government hospitals on the field. What actually is the data that the COVID warriors and the frontline medical professionals are dealing with every day. Like for instance, other than the three or four broad symptoms that you probably know of, are there any other symptoms, right? Like for instance, there's been cases where you lose sense of smell or taste. That's something that's coming up. Maybe you have a dry throat, which is not that common, but there are a lot of, maybe the recent incidents show that. There's a lot of data that on the front lines are being captured today, and we probably don't get that information because we only get the main bits of statistics, which is basically number of positive cases and so forth, right? So I thought maybe let's do one thing. Let's hypothetically think about a solution where we capture the data from the frontline, healthcare professionals. So assume that the data is captured on a mobile or any device where they actually speak into the app, right? And they don't have really a lot of time to write down things, and even if they do, collating that, aggregating that information is hard. So let's assume that most of what they're observing on the field in terms of how many patients are coming, what are the symptoms, where are they coming into, etc., demographics, what not, all this data is, let's assume for the for all practical purposes, captured from an app, which basically generates a bunch of WAV files, right, audio files. So these have obviously spoken notes from the healthcare professionals, and assume that these are the ones that need to be processed, the data extracted, relevant piece of information extracted, and then possibly stored in a location which you can run some analytics on, right? So maybe in the downstream you might have a big data processing or some sort of um, Hadoop or Databricks ecosystem of services working on data that's coming in constantly from the feed, right? So the input of this sample that I created is basically a WAV file, right? Audio files that are captured on any app, and they essentially pass through the system that the sample solution that I've built. So that is the use case, right? So using a combination of functions and cognitive services from Azure, the idea is to process these WAV files, transcribe them into text, and then run some text analytics on that text, so that you can extract entities, extract key bits of information, and then store it in a medium which can be used for big data analytics. So that's essentially what this system is all about, right? So that's in a nutshell, and I'll talk a little bit about the architectural components of the system. Um, uh, so so this is a solution that's built on Azure using Azure functions. It also leverages some native services from Azure, like cognitive services, where specifically I use speech recognition SDKs as well as the text analytics SDKs, right? So all services are native, pretty much available. Available to use in a multitude of SDKs, whether you could use them with Python, which is the case here. I've also used a bit of C# here. So it's pretty easy to integrate all these, and I'll show you the code in just a bit. So let me walk through the overall process flow, right, in terms of how this works. So the WAV files that are captured um, in from an app are hypothetically loaded to a blob container. So blob is basically the equivalent of, say, S3 in AWS, where you can have files, unstructured data just placed and used for the processing. So WAV files are essentially placed into a blob container, which then triggers a function app, right? A function. So the way Azure functions work, for those who probably are new to functions, so Azure functions are essentially the serverless capability that Azure provides. It basically is housed in a container called function app, which can house any number of functions. They're all part of the container called app service, which is associated with the plan. The plan could be to use a consumption plan, which is the case here. Like you pay as you consume kind of a model, where you just pay for the number of executions of the functions and the CPU and memory used, right? So you can execute any function, which could be written in Python, C#, Java, what have you, right? So I have one function which basically does the first job, which is take the WAV file that's placed in the blob container and transcribe it. That's the first step, right? So I should essentially use the speech recognition SDK to kind of transcribe this text and get a JSON file out of it, right? Which has basically the raw text, right? So that the output of that is again sent to another blob container, which essentially becomes the input for the next sequence of steps that will be executed. So what is that? So the next steps are basically the text processing, right? So you have so I have basically used three services here from Azure Text Analytics. So one is extract key phrases. And by the way, I'll show the example. So in case this is getting a little complex, don't worry. Bear with me. I'll show the example of how this works in just a bit. So so coming back to the text analytics services that I'm using extract key phrases. So given a line of text or a couple of sentences, key phrases or aspects are extracted out of the text. Like for example, if I say, some if I say, like for example, three patients were admitted to this hospital, your key phrases would probably include the hospital name, three patients, and so forth, right? Or if you include a date, it'll probably include that as well, right? So that is essentially some key aspects of the text. Similarly, you have entities that can be extracted using another service from the text analytics SDK, which basically allows you to again extract specific entities and know and probably use the AI to infer what it is. Like Manipal is an entity which is basically a hospital or a location, right? um, Three patients were admitted today. If that's the text, then today is an entity and it is of type date, right? And if I say three patients, three is an entity and it's of type count. So these are essentially the extracted entities out of text. And finally, I thought I'll probably add in another element of text analytics, which is essentially sentiment processing. It is sometimes, at least for me, I was interested to know, okay, what is the overall sentiment in the front line? If I were to really understand what's happening on the front line, whether the mood is grim or somber, or is it good because there are more recoveries? So is it basically possible to, while the notes are being taken by the frontline workers, let's do some sentiment processing and see if the overall sentiment is neutral, positive, negative, whatnot, right, over a period of the whole day. And that'll be maybe an interesting bit of information that you can capture and then later do some analysis on, right? So I also added that in. So which basically whatever is narrated by the frontline worker is basically analyzed for sentiment, and then that is part of your analysis as well. So I have three functions which do these three bits of text processing, leveraging the text analytics SDK, which is again part of the cognitive services ecosystem of services from Azure. And then finally, the process text, which again is a JSON file, a JSON document, is pushed into a document DB, which is Cosmos in this case. Cosmos is offering from NoSQL offering from Azure, which allows you to, in a very highly scalable way, store documents. It allows you to query based on multiple APIs. Could be SQL, could be Cassandra, Gremlin, what have you. It's basically the NoSQL solution from Azure, right? And pretty much the go-to solution for a document database, right? Equivalent to Mongo and Cassandra and so forth, right? So Cosmos is the final destination of these processed messages. So that's the flow. What I also did is the copy of these messages are also stored in another blob container, which again could be the source of processing. So let's assume it's going to a data lake, right? So for document DB allows you to run very powerful queries. You can actually use it to front end some of the applications that you've built. But then these messages could also be saved into a blob containers. Let's assume it's a data lake, which is probably the Azure Data Lake service that could essentially be also used for further downstream big data processing. So this is the solution, right? Um, so it's an end-to-end system that's completely built on serverless. I've not used any aspect of infrastructure which is set up by me and configured. So this is entirely serverless, right? Every bit of the solution is serverless. And that's the beauty of this, right? So from an architecture perspective, I'll go to the next slide. So from an architecture perspective, this sort of broadly fits what is called as the pipes and filter pattern, right? So essentially, you have a data or messages passing through a series of pipes, which helps you, take the message from one place to the other where it's processed, and that's the filter or the transformation. So you essentially have a message going through multiple pipes. They're processed by filters and then sent across to the next set of filters through another through a messaging mechanism, right? So broadly, that's the pattern, architecture pattern that I've used here. So in other words, the containers that I've used from Azure serves as a pipe. In that sense, it's a messaging mechanism that I've used. So for example, whenever a message comes, a sound file comes to a blob container, it triggers a function. And once the transcription is done, and stored in another container, it triggers another set of functions, right? So blobs is essentially the messaging mechanism, and the filtering, which is the transformation or the processing, is done by the Azure functions, which are called on demand in response to an event, right? So that's essentially the pattern. So functions are very powerful, and I'll show you, how easy it is to actually plug in multiple inputs and outputs. So you don't really have to write a lot of code. That's the beauty of functions. It's basically event based. It's asynchronous. So all of this is that I showed you is not synchronous. It's asynchronous, and therefore can scale to any extent. Like tomorrow, if you were to take my own solution, and you have millions of wave files that are just pumped in, it'll just work, right? It'll just work. So because the nature of this is event driven and asynchronous, right? And the messaging happens through blob containers, with each unit of work done by a function, which is basically transcription or text analytics, right? And the scaling happens automatically. But that's the nature of serverless in general, right? So that's the architectural pattern that I've used. I just want to highlight that this is one way to do this, right? So I've used Azure Storage blobs as a messaging mechanism. That's not the only way. There are other ways to do it. For example, you have Service Bus, which is more in terms of if you're looking at small messages or datagrams, you can use Service Bus in a pub sub model. Natively, topics and subscriptions are supported in Service Bus. That's one way to implement pipes. The other way, is, of course, is to use the Azure Storage Queues, which is a lightweight messaging mechanism that can be used for high durability, as well as for small messages or datagrams, right? I've used Azure Blobs, but that doesn't mean that's the only solution. I just used it so that the blobs can also serve as a container for a data lake or further downstream processing, right? So I just wanted to highlight that. So I'll just stop the slide part here. I think I've talked through a lot of theory. So let's probably get into a demo of how this all comes together, right? So I'll just switch to the demo part. So just give me a second here. Um, I'm hoping that you're able to see my screen, which has the Azure Storage Explorer. This is sort of the so I don't have an app. So what I'm doing is I'm simulating a frontline worker recording a message and submitting it to the system, right? So I'm just doing basically I'm what I'll do is I'll trigger the process by uploading a wave file into Azure, and the rest of the processing would just kick off automatically. So let's do that. So let me upload a file. So I'll just have some samples that I have recorded here. So the samples themselves are not very interesting, but it'll just maybe help you get a sense, right? So once this is uploaded, a bunch of processing would kick in. The first step is to, if you recollect, the first step is to basically transcribe this message and um, convert it into a JSON file that is then picked up for further downstream processing, which is the text analytics. So let's see the Azure portal. So if you can see any activity here. So not yet. So it'll just take a little bit of time. So since I've not used it for a little while, so there is the cold startup that might be there. So let's probably get back. So it'll take, depending upon the cold startup, it might take something like 10 to 20 seconds to actually run through the text process and see if any processing has happened. So not yet. So anyway, I'll explain how this the pipes part of it, right? So once I place files into sound files, the next step is that it will come to a container called SR output, if you can see here. So that triggers another set of functions which themselves do text processing, and they would output the messages to a bunch of containers themselves. So EE output is a container where I store the extract entities part of it. KP is basically key face extraction. PS is basically process sentiment. So there are 3 block containers, and I also have the final destination of the messages, which are in a Cosmos DB. So while the processing is going on, I'll explain, for example, some messages that I've already processed. Um, so just to give a sense of what the final output is like, right? This is an example that I uploaded from a test file, right? So patient 243. Let me zoom in if you're not able to see this. Just yeah. So so this is an example of basically entity extraction, right? Again, I've not used any customized trained models. This is completely out of the box. Obviously, you can actually have your own trained models based on the context and the industry you're working for. I've just used out of the box, text analytics services. So the the examples that you see are here are just out of the box, and it actually does a pretty good job without any training by itself, right? The out of the box training models work pretty well. An example of entities are essentially patient 2345. So 2345 is an entity, which is a number. He was admitted to Manipal Hospital. So Manipal Hospital is again an entity here, which is a location. And then you have today, right? So which is essentially another entity, which is date time. So the out of box text processing was able to extract this. So downstream, the way you work is you look at the confidence score. Basically, any confidence score that falls in the range of, say, again, you can set the threshold based on the context of your business application. So anything that's more than maybe zero point 0.8 or zero point 0.7 could be considered as valid. Otherwise, you might ignore it. So things like that, right? So this is something this is the output that is provided by the text analytics service, and you could use it for downstream processing. So this is how a final document looks like. Let's see if we're able to. Yeah, looks like our what we sent, which is I believe. Let's see if our process completed. Not yet. Let's see if it failed for some reason. Anyway, we'll come back to this. So let me explain the other functions that I'm using for processing here. So to get back to, so I'll just get back to the data explorer. So I saw you saw extracted entities. So let's take an example of key phrases, right? So this is another interesting bit of information. So I'll zoom in if you can see this, right? So for the same message that we saw, right? What are the key phrases? So difficulty in breathing, symptoms of cough, Manipal Hospital. These are key phrases, right? Again, this is out of the box, right? And if you train this, maybe it will be able to extract key phrases a little bit better. So this is how the key phrase extraction would look like. Again, if you think about thousands of messages coming in, you can extract, aggregate all these key phrases and then make a meaningful analysis on it. Like for example, what are the top symptoms, top five symptoms, right? We know the top three symptoms, but what are the top five symptoms, right? So the information would essentially be useful for that. Plus you can also check, since you're extracting uh, the location, the key location. So if a lot of people are going to Manipal, or in the case of Bangalore, it's probably Victoria Hospital. That's the COVID hospital, right? So you can actually understand where is the maximum inflow of testing that's happening, where are people getting admitted, and so forth, right? So those sort of analytics can come out of this automatically, right? So entity key phrases are pretty useful in the analysis as well, tied to the entities that we saw earlier. And finally, so let's see how the process sentiment looks like. So, so if I were to zoom into this, right? So again, this is out of the box sentiment analysis. Um, so there were two sentences. So you have actually sentiment analysis that happens for each of the sentences. Out of the box, I've not used any training. So if you want better sentiment analysis specific to the COVID frontline situation, you would need to train the models a little bit better. But again, for the sake of this example, I've just used the out of box sentiment analysis, right? So, but it's still reasonably good. I mean, it's of course it needs to improve, but this for the sake of this example, you'll actually see this. You get a sense of how the actual sentiment analysis work, right? For example, if I were to just talk about patient being admitted and he had symptoms of cough, difficulty in breathing, the sentiment is overall negative, right? So whereas if I were to upload a file which says that patient recovered completely, he ran through two set of consecutive negative tests, and he was discharged, the sentiment is basically positive, right? Or it could be neutral, definitely not negative, right? So again, if you were to run thousands of samples every day, you could actually aggregate these sentiments and see what the overall mood is like, right? Whether there are more recovery, you can actually infer whether there are more recoveries, whether the symptoms are less severe than usual. More people are recovering. These sort of analysis we can infer from these scores downstream, right? I've not actually implemented the downstream part, so that's a good exercise to do. But you get the idea, right? So if I were to run key phrase extraction, sentiment analysis, and the the key entities, I can actually combine the data to actually get a better sense of what's happening in the field, right? So that is the overall value of actually running raw data, which is just people speaking into a phone or an app, and then having it run downstream with the big data processing tools like Databricks or Spark or what have you, right? So that's the essence. I hope this you at least got a sense of the solution here. Although of course it has it has a lot of again, this is a very basic solution that I built, just maybe in a day or something. But the idea is that you get the value of actually bringing these components together, right? So that is the value. So the text analytics, speech recognition, along with functions with the built-in bindings, makes it very scalable and very powerful way to actually create these systems at scale, right? So that is the value. So I'll just go to the portal to show you some aspects of what the system, what are the components that go into the system. So the function app, again, if I were to go back to the architecture slide again, so let's go one by one. So the first one aspect of this is the text analytics part. So let me show you what the text analytics. So this is a function app that has three functions, right? So each function essentially, if I were to go, for example, what each function works like. So it's so the function is the code that I'll show you in just a bit, which um, uh, basically does, I mean, the main job of this function is to call the speech recognition SDK where transcription is required. And in this case, calling the text analytics SDK, which is part of the cognitive services family, right? The input or the trigger for that is basically a blob storage. So the transcription file coming into um, um, the transcription files coming into the blob container is the trigger that triggers this function. The output is two things here. The same file, which is basically a set of extracted entities, go into Azure Blobs and Azure Cosmos DB, right? All of this is wired automatically. I actually don't have to understand aspects of polling the blob container to pick up the wave, the JSON files, and then figuring out how to take my processed text and then push it to the Cosmos DB, right? So this entire function does not I don't have to worry about the plumbing, the actual plumbing that goes into pulling the data from the input and pushing it to the output. So that's all done automatically. So I'll switch over to the IDE. So I think many people are asking how this is built. And by the way, all of what I talked about is on GitHub. So I will share the deck and all the links that are relevant to this presentation and the source code. The code for this, the entire code for what I've used end to end is shared on GitHub, which I'll also share. It's mentioned in the deck as well. So this is what the code looks like, right? So I have two functions, one for speech recognition, which is written in C sharp. This part of the code is written in C sharp. However, all the text analytics is written in Python, right? So how does the actual code look like? So let's go to extract entities. So the extract entities part is essentially one second. I don't know why it's a little frozen here. Just give me a second. Okay, so let me. So how does the function looks like? So basically, you got to have an underscore init underscore py or double dunder init py, which is where your actual function runs. As you can see, you get as input a stream that basically represents the blob that has either in the case of speech analysis, in case of the speech, it will have the wave file, or in the case of text analytics, it will have the processed JSON file. So that is your input. And the output, again, you get two variables or two arguments which you can use to send the processed output to, right? Again, the actual plumbing in terms of how this is sent is abstracted from you. So that's a beautiful part. So if you can see, the entire, pretty much the entire code is just this, right? So I basically have a small helper function, which is calling the extract entities SDK. So that looks something like this. It's very straightforward, barely 20 lines of code. So I'm just using the text analytics SDK. So I authenticate against the API by passing the key. The keys are part of the configuration. In That's part of the that's basically configured in the function app. Typically, you would need to secure the keys. So I've used Key Vault, which is the a secure place to store keys, API keys, any sort of certificates or secrets, and I'll show you that also in a bit. So I just call the SDK, which basically gives me a response, which is nothing but a bunch of entities, right? This is the extract entities function, right? So what I do is essentially enumerate to them and create a dictionary, and then pass it back to the to my function, where I basically convert it to a document, a JSON document from a dictionary, which there is a helper function for it that the SDK provides, called from dict, as you can see here. So and then I just do a doc.set, which takes the JSON document and pushes it to Cosmos DB. So I don't really have to worry about the plumbing, right? So that's as easy as it can get. So just probably 20 lines of code to call the SDK, formulate the output as a JSON document, and push it to the, Cosmos DB. So that's essentially how it is. How is the function configured? Like I said, you actually, in Azure Functions, you have the notion of bindings, where you have a bunch of input bindings and output bindings, right? The input bindings is basically how the messages come into um, how the messages come into the system, through most typically through a trigger, right? You can have an HTTP trigger, which basically you use for APIs. In my case, it's a blob trigger, right? The blob trigger triggers the function, and then the output is basically sent to a container and Cosmos DB, right? So that's essentially how each function is configured. So I just showed you one example. The same is the case with uh, key phrase extraction. Exactly the same thing, and process sentiment. So pretty much the same. So how do you basically push the functions to Azure? It's very straightforward. Visual Studio Code, which is the IDE that I use and I recommend, is essentially has a bunch of add-ins which help you automatically publish to Azure. So I'll just show you one example here. So so all you need to do is basically connect to Azure here, and once you're done with the function, you can actually right click and publish, right? Or you can actually use the toolbar here. Another alternative way to do it is from the command line. You can actually you can use the Azure Functions developer tools, which gives you a bunch of CLI utilities, just as you can see here. So you can just do like func init to initialize a function, func Azure publish to publish into Azure. You can actually do func start, which runs the function locally for your local debugging and testing, and so forth, and func logs to extract logs, which you can use for debugging as well, right? So so you can install the Azure function core tools and the add-ins that come with Visual Studio Code that will help making this very easy. So I'm running a little short on time, so I'll probably at this stage. Rohit, how much time do we have?
Uh, you have
Okay.
around 15 minutes.
Let me. Okay.
Uh,
So
yeah.
yeah. So this is the code that I just want to show. If there was a lot of things to process, don't worry. The code along with an article that I've written. So I'll just show you that. So corresponding to this sample that I've created, I also wrote an article on Medium, which you can actually take a look. This explains the overall flow, the architecture, the thought process behind it, the considerations and everything, along with the link to GitHub, right? So this is also available. Most importantly, if you're new to functions and you thought this is a little overwhelming, don't worry. The basic premise of why I created the sample was to actually uh, create a sample based on some of the popular MS Learn learning paths available on the new Microsoft Learn platform. Pretty awesome. I would strongly recommend you to go through them. Very, very good. So I kind of leverage some of the learning paths that I went through. Like, for example, this is the one for creating serverless applications. I use that learning to actually create a sample, right? So there are a lot of the MS Learn provides an SDK. Provides a sandbox which you can use without any provisioning of Azure yourself. It is a built-in sandbox that you can play around. Pretty awesome, right? So I kind of built the sample using the learning modules, and I've given the links to the samples that or the learning paths that I have used. So if you're new to functions, or if you felt this was a little overwhelming, don't worry. You can actually go through each of these learning paths, and it's very, very good. Plus, you can always reach out to me if you have any further questions offline, so not a problem. And then the code is available in GitHub. The entire code is available in GitHub, so not a problem, right? So that is pretty much the sample. So let's see if for some weird reason, the initial processing just failed. Let's see if it went through. Yeah, looks like it has processed. So this COVID-6, it took quite a while, but yeah, it's eventually done. Um, so let's see that. Yeah, so this is the, yeah. So this particular one was basically patient 1234 were discharged from Victoria Hospital. He tested negative on 2 occasions, right? So this also got processed. So if I were to see how this, it took a little longer. We can investigate here. So, well, there you are. So this, if I say last 30 minutes, okay. So here we go. So it did run through. The process file took around 5.7 seconds. This is basically all the time it requires to transcribe a WAV file, and then the extract entities took 3 seconds. Key phase extraction took 3 seconds, and process sentiment took around 2 seconds, right? Because most of the time is actually spent in the is spent calling the SDK, right? If I were to expand this, so this is, by the way, application sites built-in application performance tool that is part of Azure. Pretty good. So it'll help you debug issues here. So if you see the actual input and output to Azure containers as well as Cosmos DB took pretty much very little time. A few, sometimes as little as 17 milliseconds. But the actual processing was because of the SDK that I called to actually, in this case, extract process sentiment, right? So you can actually see it took 3 seconds, but the time it took to read the documents from the Azure storage and then push it to Azure Cognitive Cosmos DB was actually pretty less, pretty good. So this is a way to debug your functions, which is integrated into functions, Azure Function Apps. Pretty slick. You can go through this. Okay. So so at least yeah, we do have an end-to-end sample here. Although it took a little time, yeah, but it was asynchronous entirely, right? So you get the idea. So I'll just probably pause here for maybe we have 5 minutes. I'll probably take a look at some questions here. So okay. So many people are asking for the links. So the deck that I'm going to share has the article on Medium, which explains what I have. Basically, So you can take a look at this. The source code is on GitHub. That's also provided in the deck. All the references, which are the wonderful learning paths that you can go through for cognitive services and Azure functions, are all listed here. You can actually go through each of these. Pretty much, even if you're starting from scratch, you can go through these. They're very, very good, right? Evaluating text with cognitive services, processing and translating speech, all, and of course, this link is actually a book which is free. It's an MS Press or or maybe Pact actually, which is made available as free. This is also pretty good. And then of course, serverless apps patterns and implementation is also another book, in fact, which you can go through. Pretty interesting book. And creating serverless applications is a MS learning path. It's a course, which is also pretty good. So even if you're starting from scratch, don't worry. You'll get through this in a breeze, right? Um, so that's all I had. Feel free to reach out to me, Rohit, if you have any questions. I'll come to Rohit. You can maybe flash some of the questions. I'll maybe take them. But I'd like to leave you with one more note or a thought. I mean, interesting initiative that is going on. Azure Dev Stories is an initiative where we're trying to collect developer stories from the community, from developers who are building very interesting solutions on Azure, especially in the COVID situation. If you're using, like I did, a combination of functions, cloud native, AI to kind of build interesting applications. If you have stories on learning and developing, please submit them to Azure Dev Stories. The link is here. And also, I'm looking forward to your participation in Cloud Community Days, CC Days, which is happening in the second week of June, so 17th to 19th, online. Feel free to register. It's like an awesome collection of speakers and sessions over 3 days. So looking forward for your participation there as well. Okay, so coming over to questions. So I think I have a few minutes. So I'll probably go over some of the questions here. Just give me a second. Um, okay. I think most of the questions I see are essentially around the links to the Medium article as well as the GitHub. Rohit, any other questions that you see that I'm missing here?
Yeah, actually, there is a Sri who is asking, can you explain about the blob container? I'll just show it on the screen.
Okay. So yeah, no problem. So blob container so is essentially Azure Blobs is a part of a storage service that Azure provides, highly scalable, highly durable storage service. So Blob is one of the ways you can actually store any file, like a could be an unstructured file like a wave file, or any document or CSV, whatever have you, right? So in Azure, storage is organized as storage accounts, and each account can have any number of blobs, and each blob containers. And let me show you that. So this is the I hope you're still able to see. Um, so on the left side of my Azure Data Explorer, you can actually see storage accounts. So storage accounts are a way to organize storage, large amount of storage, which you can do in like 2-3 ways. Blobs are essentially where you store, typically binary files or any unstructured data. File shares are essentially a way to store files and access them through protocol like SMB, like in a networking share. Queues are essentially a messaging mechanism which allows you to build. You can actually use it as a for processing messages asynchronously as well. And then tables are again another NoSQL way of storing data. This was again way before Cosmos DB came in. Tables was the only native option in a NoSQL way to store a very large amount of data in a key value fashion, right? So there are three. These are the basically in a general purpose storage account, which is in my case, it's called as the NC Cognitive Toolkit. I can actually organize my storage into blobs, files, queues, or tables, right? In the case of my example, I've used blobs, and within blobs, I've used what are called as containers. Think of them as folders. Like in this case, I have one folder for the input, which is sound file. Then I have four folders for output, which is basically called E output, KPE output, and so forth, right? So these are, think of them as logical folders, which you can configure for triggering in the function apps. So I hope that answers the question. So I also see, okay, do you have regional language support for speech to text? Yes. So I think at the moment, I think it's only Hindi. So I'll have to check. I mean, this is an evolving, the speech SDK is evolving, so it might not have all the the Indian languages yet. I believe there is support for Hindi, but I'll have to check the documentation. So obviously there is support for the more I mean, like Spanish and French and other the whole bunch of other languages. But I think the Indian languages support is coming soon. But I think you'll basically have to wait for support of all the 8 or 9 core Indian languages. So um, is there any other question? Do we okay? So I can't. Everything else seems to be related to the links, right, Rohit? So anything else that I'm missing or
Yes,
any?
I think that's all for the questions. You have almost answered all the questions.
So you can see one more follow-up question. So is the output processed when the output is processed, it goes to the blob container. So it's the same blob container used earlier. The answer is no. One so uh, the so I have a bunch of input blob containers. So the sound files is an input container, right? It triggers one function which sends the output to SR output, for example. So yes, for in this particular case, the output of one function becomes the input of the other. So if that's a question, the answer is yes. But typically in a messaging mechanism, they may or may not be the same. But in my case, for text processing, I'm using the output of speech as an input for the text processing. So if that I I hope that answers the question. Okay, so probably running out of time here. Again, I breezed through a lot of concepts very quickly, but I hope at least the resources that I have will help you offline. If you need any questions, feel free to reach out to the meetup. You can always ask the questions through the meetup channel, or reach out to me directly over Twitter or LinkedIn or email. So my contact information is provided in the deck. We will be uploading the deck as well, or probably Rohit has already done that as we speak. So again, thanks for the opportunity. It was really fun being part of the PyCloud mini event, which is I think is a great line of speakers. I'm pretty honored to be co-presenting with many of the speakers that are coming up or have already presented. So thanks so much for the opportunity. Thanks for being patient through probably a very dense talk, but I'm hoping it'll be useful when you go through the GitHub and the articles. So that will probably make a lot of sense. Over to you, Rohit.
Thanks a lot, Manoj, for the talk. Like, we are really glad to have you uh, for sharing your knowledge and everything. So, I hope everybody would have loved your session and would have learned a lot. And also regarding your session slide and the links, we have always shared it through the comment box, but also in the post-event mailer, we'll be sharing it with the audience. So, guys, as Manoj mentioned, like we are coming up with another conference. It's called Cloud Community Days. So we have already mentioned the link in the comment box, so you can check it out. Thanks a lot, Manoj.